Today, I'd like to pitch to you the idea of underwater data centers. This is an idea that I think is particularly relevant today with the explosion that we're seeing of data across the internet, across cloud, across the communication that we have between humans and computers and all these AI models and everything like that. So to introduce this topic, I first want to set up the problem with existing data centers. This is a picture of one of the largest data centers in the world. This is Google's data center in Belgium. These are both of the same data center. So on the left, we can see that there's a large area of land taken up by this data center. And on the left side at the very edge is actually the data center itself. And then you have these huge amounts of electricity generation plants that actually convert electricity from these long voltage transmission lines down into the voltages used by the actual computers in these data centers. Now, these data centers are renewably powered. So for example, this data center has a large solar farm next to it that's used to actually power this data center. So in theory, it's carbon neutral. But this comes at a cost. One of the major costs with building a data center like this is that it's a huge amount of investment to be able to occupy this much land in a space like this. And also, the main bottleneck in energy consumption for these data centers is actually in cooling the equipment in these centers. It's not so much in actually powering the computers that are inside these server racks. So a lot of the power that's generated by these solar farms goes into cooling the data center rather than actually being used for computational workloads. For example, every time you do a search on Google, or let's say you run an ML model to query some kind of feature or image kind of pattern recognition, those kinds of tasks are actually being relegated to the back burner compared to the amount of energy being used to cool these data centers. So a major bottleneck in energy consumption is cooling. Now, there has been a lot of work done on floating data centers. And the main benefit of these floating data centers, which this proof of concept shows here, is that by putting the data center directly on top of a body of water, you can use the water right there to cool down the data center. So you can have water flowing through a river, for example, that just naturally comes in at a cold temperature, flows through your data center, extracts the heat, and then is expelled out the other side in a natural kind of cooling mechanism. Now, this is nice, but the problem with these data centers is that the power consumption is still dependent on onshore generation. So for example, you'd still need a solar farm or some kind of onshore power plant to feed the power to these data centers. So even though in theory they're self-sufficient in terms of cooling, they still need to be tethered to on-land power sources. So in that sense, you're having an area cost both on land and on the water. So this isn't that great. So let's take this a step further. And this is the idea that I'm pitching, which is underwater data centers. The idea is for these data centers to be completely underwater. In fact, ideally, they'd be on the ocean floor itself, instead of floating next to a piece of land where they could extract power from an onshore generation center. There has been some work done on these data centers. For example, Microsoft has actually deployed an underwater submersible data center that sits about 120 feet below the surface of the water on the seafloor. And you can see that there's all kinds of ballast tanks and submersibles that are used to control the sinking of this data center from the surface down into the water. The problem with these data centers, though, is that they're very small today, and there's only a few of them that are deployed actually underwater. So what I'm proposing is that we deploy more of these data centers underwater at scale across the ocean, not just next to land. And the main idea behind this would be that we use underwater ocean turbines to actually provide the power for these data centers. So we don't need to have these data centers tethered to onshore power generation anymore. We can have these underwater wind turbines, essentially, that generate power through the flow of ocean currents. So we have the ocean currents providing power to the data center. And we also have the water providing cooling to the data center, making it entirely self-sufficient and sort of self-contained underwater. Now, you might be asking an obvious question, which is like, okay, if you put a massive data center underwater in the middle of the Pacific Ocean, for example, how do you actually transmit data to that ocean center? And how do you receive data from that data center if you're going to be doing this in a low latency environment like search engines or like very compute intensive machine learning workloads? Well, it might surprise you all to know that today we have thousands and thousands of miles of fiber optic cables that are actually laid on the ocean floor around the world. And the scale of this is truly mind-boggling. We have cables that go from every continent to the other except for Antarctica, And these cables have been deployed on the ocean floor since the mid 20th century. So these cables are already being used to supply close to 90% of today's international data traffic through fiber optic cables on the ocean floor. So by interfacing data centers on the ocean floor with these cables, we can simply just insert them into the existing data communications infrastructure without having to expend a lot more effort on how to integrate these data centers with the rest of our communications and networking equipment today. So I hope you all consider this idea, because I think it's a possible way to make these data centers entirely self-sufficient. And I think it's a way to really exploit the natural resources we have on the planet to enable efficient and sustainable data centers.